Indeed, we conducted a molecular organic geochemical approach. Essentially, it's a mechanism that you can use looking at individual compounds to essentially get a fingerprint of the different types of oil or material to try to link it back to its general origin. What we're seeing here is this is a gas chromatograph of individual compounds that come out of a machine, and this is the oil that comes out of the riser pipe. And interestingly, this is the oil that you see in the surface. So it's gone through some sorts of transformation, so it's not immediately apparent, or it's not that easy to be able to tie one to the other just simply based on some of the general characteristics. But what one does see is, indeed, this is the classic example of what they call the M252 oil from the Deepwater Horizon. And this has also been chemically linked through some compounds that are associated down here that are called biomarker compounds that are very, very distinct and very unique to a particular type of oil. Not only their distribution, but their relative abundances as ratios can be used to delineate one source of oil from another. So this is the sort of thing that we were able to see and have material for that is distinctively the Deepwater Horizon oil. Again, if you make a comparison between the riser oil, the degraded oil that has chemical linkages between the two, so you can actually match these two oils, although you may not see that so apparently. You can see a gradual trend as you move from the 400 particles to the 1,000 meter particles. There seems to be compositional shifts that are going on with this oil. Why those shifts are occurring are still signs to be done, but there's either the prospect of, again, biodegradation, different rates at which microbes are starting to consume the material, or the use of dispersants, which can selectively isolate certain components of the petroleum. That's certainly the case. So again, the degradation sequences, you'd expect these kind of compounds to be degraded before the aromatic compounds like the polyaromatic hydrocarbons. You'd expect the low molecular weights to go before the heavy molecular weights and the short chains to go before the long chains. And that's sort of exactly what you see. You see this progressive loss of short chain and alkanes. So the two hypotheses, again, of biodegraded oils with microbial partners that are essentially degrading this, and there is some chemical signatures that suggest that. Others that is clearly a very important one is the use of the dispersants, which could cause selective loss of the molecular weight components and liberate them into subsurface oil horizons or layers. And again, there's some things that we just do not know about the organic geochemistry and about how oil and how it interacts, especially at those high pressures coming out of the wellhead. What is the physical chemical interactions between the oil, the gas, the formation waters, the seawater, and the dispersants? These are all really important characteristics when one's talking about how does the oil interact with the surroundings when it comes out of the wellhead at 8,000 psi.